All right, everyone. The Subcommittee on Research and Technology will come to order. Good morning, everyone. Welcome to today's hearing entitled The Future of Surface Transportation. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witnesses. I now recognize myself for 5 minutes for an opening statement. The research and development activities of the Department of Transportation are vital to our nation's prosperity. These efforts support the critical infrastructure and enhance both our economic competitiveness and way of life. The pathway forward for these programs continues to present significant challenges for Congress. We need to ask difficult questions to determine how best to address the issues facing our aging infrastructure within the limitations of our current budget environment. In addition to my role as chairman of the subcommittee, I also serve on the House Committee on Transportation and Infrastructure. In that committee, we have had several hearings on new car technology, for example, and what the role Congress has and DOT have in research and testing this technology. In 2014, the DOT annually supported more than $1 billion in research, development, and technology deployment activities focused on surface modes of transportation. These programs were last authorized in 2012 in the Moving Ahead for Progress in the 21st Century, or MAP 21, on which I served as a conferee. These programs are primarily supported through the Highway Trust Fund and Mass Transit Fund. Trust Fund revenue at its current spend rate will be insufficient to carry out authorized programs. The Transportation and Infrastructure Committee is currently considering how to resolve this problem before trust fund depletion. Advancements in materials and technology such as connected vehicles, autonomous cars, and positive train control can help achieve long-term cost savings by reducing congestion, increasing economic output, reducing environmental effects, and improving the durability and lifespan of our transportation projects. It is therefore critical that we find a way to maintain a healthy, substantive research base behind our state and local transportation initiatives. Today's hearing will allow us to examine research, development, and technology priorities at the United States Department of Transportation and understand the important policy issues regarding the future of surface transportation. In addition, this hearing will provide an opportunity to understand RD&T activities in surface transportation both at federally sponsored research institutions as well as RD&T conducted by the private sector, and understanding how these advances are being utilized by state and local governments. I look forward to hearing today's testimony and to a productive and fruitful discussion on U.S. surface transportation, research, development, technology, investments, priorities, and policies. I hope you will continue to work with us to maximize the effectiveness of surface transportation RD&T programs as we attempt to reauthorize our federal surface transportation programs. Again, thank all of you for joining us today. It's very much appreciated. I now recognize the ranking member of the committee, the gentleman from Illinois, Mr. Lipinski, for his opening statement.
Thank you, Chairman Bouchon. Thank you for calling this hearing. I also want to thank our witnesses for appearing before us today and for their assistance in helping us identify the research, development, and technology needs to ensure safer and more efficient transportation in our daily lives. We all have multiple places we need to get ourselves and our families to and from in a day. We all wish that we could do it quicker and cheaper. The average household spends 17% of its budget on transportation. In all, transportation-related goods and services contribute about $1.2 trillion to the U.S. economy. As a member of the House Committee on Transportation and Infrastructure, along with Chairman Bouchon, I've been able to work on several bills to authorize funds and set policies for road, rail, mass transit, aviation, and other critical transportation projects across the country. I cannot overemphasize the need for long-term investments in transportation to keep people and commerce moving. As we focus today in this hearing on the future of surface transportation, I look forward to learning more from our witnesses about what this committee should be thinking about including in the research title of the upcoming surface transportation reauthorization. If we are committed to making our transportation system more reliable and more efficient, while at the same time ensuring that transportation planners are wisely investing taxpayer dollars, we need to have a robust and effective transportation R&D policy. This subcommittee last examined transportation R&D in 2011. Since then, Congress has passed MAP 21, the 2-year surface transportation reauthorization law that expires this year. In the past, we have examined a number of research and development challenges faced by the Department of Transportation. Some of these challenges have included improving planning and coordination at DOT, strengthening technology transfer, and environmental mitigation. These remain important topics for discussion today. Safety is a top priority across all of DOT's research programs. I look forward to an update on the progress DOT and the private sector have made in developing vehicle-to-vehicle communication and other technology for safety and what barriers these face for full-scale deployment. Many of these technologies are precursors to the technologies we will need when we eventually deploy self-driving cars. I visited a Google campus in Mountain View, California last December and saw the rapid progress they are making towards autonomous vehicles. V2V and V2I technologies have the capacity to greatly increase safety and efficiency in transportation, and I believe autonomous vehicles are the logical way to maximize these gains. At the pace technology is currently progressing, I often ask people, do you think a child born today will ever have to learn to drive a car? At this point, I think it's an open question. But we shouldn't focus solely on roads and highways. Rail transportation is hugely important for my district as well as the nation. Nearly a quarter of all freight rail traffic in the U.S. passes through Chicago and is a major hub for passenger rail as well. Moving forward, we must invest more in R&D to ensure the safety of our rail passengers and operators. Preventing another tragedy like the Metro North train derailment in New York and the Washington Metro train collision must be a priority. I look forward to hearing from Dr. Barkin about the latest in rail and rail safety research being conducted at the University of Illinois. Through the University Transportation Center program, universities such as the University of Illinois play key roles in transportation R&D. Most DOT-funded research is applied research and development to address short-term needs and opportunities. Only a small fraction of the transportation research budget is dedicated to longer-term research. But it's through the longer-term research that will yield the big breakthroughs for a safer, faster, and less expensive transportation future. We need to ensure that universities are given the flexibility to pursue long-term research and that DOT continues to invest in mid to long-term research through other programs, such as the Exploratory Advanced Research Program. The Committee on Science, Space, and Technology should play an important role in defining our transportation research priorities in the future. I'm confident that today's witnesses will give us some solid ideas for moving transportation research forward. I want this committee to be actively involved in writing the research title in the next Surface Transportation Reauthorization Bill. Again, I want to thank Chairman Bouchon for calling this hearing, and witnesses as well for being here. Look forward to your testimony and a productive discussion. With that, I'll yield back.
Thank you, Mr. Lipinski. I now recognize the chairman of the full committee, Chairman Smith, for 5 minutes for his opening statement.
Thank you, Mr. Chairman, and thank you for holding today's hearing. The future of America's transportation systems is rooted in the effective development and use of new technologies. Technology allows us to enhance both the capacity and safety of our roadways, to better control traffic congestion, and to extend the life of our transportation infrastructure. The Moving Ahead for Progress in the 21st Century Act of 2012 outlines the Department of Transportation's research, development, and technology priorities. These priorities include promoting safety, reducing congestion, improving mobility, preserving the environment and existing transportation systems, enhancing the durability of our infrastructure, and improving movement along our transportation systems. Taxpayer investments in these areas should be targeted to achieve desired outcomes. The investments we make today will transform the future of transportation. One example is the development of intelligent transportation systems. Such cutting-edge concepts encompass a broad range of information and communications technologies that have the potential to improve the safety, efficiency, and performance of our nation's transportation system. In my home state of Texas, the Texas A&M Transportation Institute, TTI, works to develop interdisciplinary solutions to the challenges that face all modes of transportation. And I appreciate having a witness today, Mr. Maddox from TTI. Look forward to his testimony later on. TTI has saved the state of Texas and the United States billions of dollars and thousands of lives through innovative strategies and products developed through its research and implementation programs. For example, TTI conducts groundbreaking research to explore the interaction between driver, cell phone, and roadway, and assesses the dangers and causes of distracted driving. The problems studied at TTI are good examples of how science can yield solutions to societal problems. It shows that efficient, targeted R&D can help develop new innovative ideas and technologies that will make our transportation systems safer. Mr. Chairman, I regret I may have to leave momentarily because of a markup in the Judiciary Committee that started at 10 o'clock. But I also want to thank another witness, Ms. Tabar, for the increasing presence of Toyota in Texas. Please keep it up. Thank you, Mr. Chairman. Yield back.
That was a good plug for Texas, Mr. Chairman. Thank you. If there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. This time I'd like to introduce our witnesses. Our first witness is the Honorable Gregory D. Winfrey, the Assistant Secretary for Research and Technology at the U.S. Department of Transportation. Mr. Winfrey previously served as the Research and Innovative Technology Administration's Chief Counsel, Deputy Administrator, and Acting Administrator, and as Chairman of the Department of Transportation's Innovation Council. Mr. Winfrey also served as Chief Litigation Counsel for Freeport McMoran Corporation and as Director of Litigation for Wyeth Pharmaceuticals. Mr. Winfrey earned a B.S. degree in Communications Public Relations from St. John's and a J.D. from Georgetown University. Thanks for being here. Our second witness is Mr. Scott Belcher, the President and CEO of the Intelligent Transportation Society of America. Prior to joining ITS America, Mr. Belcher served as Executive Vice President and General Counsel at the National Academy of Public Administration. Mr. Belcher holds a Juris Doctor from the University of Virginia, a Master of Public Policy degree from Georgetown, and a Bachelor of Arts degree from the University of Redlands. Thanks for being here. Our third witness is Mr. John Maddox, the Director of Collaborative Program Strategy at Texas A&M Transportation Institute and the University of Michigan Transportation Institute. Mr. Maddox previously served as the Associate Administrator for Vehicle Safety Research at the National Highway Traffic Safety Administration, or NHTSA. Before working at NHTSA, Mr. Maddox spent over 5 years with Volkswagen Group as a compliance officer and 14 years with Ford Motor Company as a senior research engineer. Thank you for being here. Our fourth witness is Ms. Kristen Tabar. Did I pronounce that correctly? Ms. Tabar is the Vice President for the Technical Administration Planning Office at Toyota Technical Center. Prior to her current assignment, Ms. Tabar was the Vice President of Electrical Systems Engineering. She previously served as General Manager for Electrical Systems 1 Department. Prior to joining Toyota Technical Center, Ms. Tabar worked as a contract engineer with a Ford supplier. Ms. Tabar holds a Bachelor of Science degree in Electrical Engineering from the University of Michigan. Thanks. We're getting there. Our fifth witness is Dr. Christopher Barkin. Dr. Barkin is a professor and George Crambless Faculty Fellow at the University of Illinois at Urbana-Champaign, my alma mater, by the way. Thanks for being here. He also serves as Executive Director for the Rail Transportation and Engineering Center. Prior to moving to the University of Illinois, he was the Director of Risk Engineering at the Association of American Railroads. Dr. Barkin received his bachelor's degree from Goddard College and his MS and PhD from the State University of New York at Albany. Thank you. And our final witness is Troy Woodruff from my home state of Indiana. Mr. Woodruff currently serves as the Chief of Staff for the Indiana Department of Transportation. Previously, Mr. Woodruff served as the INDOT Deputy Commissioner of Operations. Before joining the Indiana Department of Transportation, Mr. Woodruff held consecutive regional director positions with the Indiana Department of Environmental Management and WellPoint. Mr. Woodruff is a graduate of Indiana State University with a degree in communications. Thanks for being here. And thanks to all our witnesses for being here. I know you have to take a lot of time to prepare and to travel to be here. It's very much appreciated. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which the members of the committee will have 5 minutes each to ask questions. I now recognize Mr. Winfrey for 5 minutes to present his testimony.
Thank you so much, Chairman Bouchon. Ranking Member Lipinski, Chairman Smith, and members of the subcommittee, thank you for the opportunity to appear before you here today to discuss the challenges and future opportunities of the Department of Transportation's Surface Transportation Research Programs. I have submitted my full testimony for the record, so in the interest of time, I will highlight a couple of major themes from my testimony, and then I'm happy to respond to your questions. Transportation research, technology, and data are critical tools for improving the safety, efficiency, mobility, capacity, and state of good repair of America's transportation system, and for reducing transportation's environmental and societal impacts. The Office of the Assistant Secretary for Research and Technology is pleased to continue to lead the department's research coordination efforts, driving cross-modal collaboration to meet 21st century challenges. While my written statement touches on a broad cross-section of the department's surface research programs, I'm going to discuss two programs managed out of my office that will help us meet these challenges. First, the University Transportation Centers program, covering over 120 universities which bring expertise in multiple disciplines, both traditional, as in civil engineering, and not traditional, such as public health, psychology, sociology, studying safety culture, human factors, etc. UTCs enable the systemic, interdisciplinary, cross-modal research we need to address increasingly complex challenges that cross traditional boundaries. UTCs do this while educating undergraduate and graduate students in the technical and problem-solving skills we need going forward, which is a win-win if ever I've heard one. I always enjoy the opportunity to meet with the bright young students at our UTCs, to hear about what exciting new things they're developing in the laboratories and in the classrooms, and how their own lives are changing, even as they add to our transportation knowledge. I certainly encourage the members of this committee to take those opportunities to meet those students as well. The second significant research program I'd like to highlight is the Intelligent Transportation Systems Research Program. The department has completed the Connected Vehicle Safety Pilot Program in Ann Arbor at the University of Michigan Transportation Research Institute. That research informed the resulting National Highway Traffic Safety Administration's, NHTSA, February decision to move forward with vehicle-to-vehicle communication technology to enable significant accident avoidance and other safety applications in light-duty vehicles. This technology will improve safety and has the potential to reduce non-impaired crashes by up to 80%. It would do so by allowing vehicles to talk to each other and ultimately avoid many crashes altogether by exchanging basic, anonymous safety data such as speed and position 10 times per second. This major decision was based largely on the research, technology developments, test deployments, and data collection and analyses conducted under the ITS research program. The department continues to work collaboratively across the operating administrations toward connected vehicle applications for heavy-duty vehicles, and our colleagues at the Federal Highway Administration are preparing to issue guidance in 2015 for installing vehicle-to-infrastructure applications for roadway safety and improved traffic operations and maintenance. Additionally, ITS is using connected vehicle technology research to reduce congestion, improve road weather information and real-time data capture, and reduce emissions. I note that all of this success and the standards that support it are based upon the availability of the 5.9 gigahertz dedicated short-range communications spectrum. Allocated in the U.S. and internationally for transportation safety, the 5.9 gigahertz band was specifically selected to enable the 10 times per second exchange of information needed to bring to reality the safety improvements that remain the primary goal of ITS research. We are actively involved in ongoing discussions related to the FCC's proposal in its notice of proposed rulemaking to permit unlicensed devices, e.g. broadband Wi-Fi and uni devices, to operate in the 5.9 gigahertz spectrum currently licensed for DRC. The department also intends to participate in the National Telecommunications and Information Administration's upcoming technical analysis related to understanding the interference and sharing of the 5.9 gigahertz spectrum. Sorry, watching the clock go down gets you a little antsy. We believe that the FCC and the NTIA must ensure that unlicensed devices do not compromise safety through harmful interference to the ITS architecture, operations, or safety-critical applications if permitted to operate in the 5.9 gigahertz band. We have very serious concerns about any spectrum sharing that prevents or delays access to the desired channel or otherwise preempts the safety applications. At this time, the Department is unaware of any existing or proposed technical solution that guarantees interference-free operation of the DSRC safety-critical applications while allowing Wi-Fi devices to share the 5.9 spectrum. So in closing, I'm excited about the research being conducted at the U.S. Department of Transportation. We are addressing serious issues in serious ways for the benefit of the traveling public. I look forward to answering your questions.
Thank you very much for your testimony. Appreciate it. I now recognize Mr. Belcher for 5 minutes to present his testimony.
Thank you. Good morning, Chairman Vachon, Ranking Member Lipinski, and members of the subcommittee. Thank you for inviting me to testify on the future of surface transportation and the research and development efforts underway that will drive this nation to developing a fully modernized 21st century transportation system. The Intelligent Transportation Society of America is the nation's largest transportation association that brings together transportation, technology, and research communities to promote technological solutions for our nation's safety, infrastructure, and mobility challenges. About half of our nearly 500 members are public agencies, university transportation centers, and research labs. The other half are private sector companies that range from the automobile manufacturers to high-tech telecommuting or telecom, tolling, infrastructure firms, actually all the way to small businesses, startups, and entrepreneurs. Intelligent transportation systems represent the future of surface transportation, especially in a resource-constrained environment. And they encompass a broad range of information and communication technologies that are and that will continue to improve system performance. Examples of intelligent transportation systems include synchronized and adaptive traffic signals, electronic tolling and payment systems, real-time traffic, transit, routing, parking, and freight systems, collision avoidance and response technologies, vehicle-to-vehicle technologies, autonomous vehicles, high-occupancy toll lanes, among many other high-tech solutions. So it's really a very broad platform in which we're looking to try to bring solutions to our system. As you know, and as Assistant Secretary Winfrey has mentioned, in February, the Department of Transportation announced that it was moving forward with the deployment of vehicle-to-vehicle communications technology. Also, as Assistant Secretary Winfrey said, USDOT estimates that this will reduce crash scenarios, unimpaired crash scenarios, by more than 80%. That's huge. It's bigger than seatbelts, it's bigger than electronic stability control, it's bigger than airbags. This was a major milestone for the future of vehicle safety and traffic congestion, and it's been the result of many years of research in vehicle-to-vehicle technology by the Department of Transportation and by the private sector, by the automobile manufacturers. Without this collaboration, we wouldn't be where we are today, at the poised to move towards deployment. Connected vehicle technology truly represents the next giant leap for vehicle and highway safety. Historically, the automobile industry has focused on protecting people in a crash. This new technology will allow the auto industry to focus on preventing crashes. Imagine a transportation system where cars don't crash and how different that could be. Imagine the vehicles that can be built when you're not trying to protect people on those crashes. Vehicle-to-vehicle communications technology operates on dedicated short-range communications within the 5.9 gigahertz band of spectrum. This spectrum was set aside by the Federal Communications Commission to ensure high-speed, accurate, secure, and reliable communications, which are critical for connected vehicles. It's essential that the availability and performance of the spectrum is protected for safety purposes, while also freeing up additional spectrum for Wi-Fi where it makes sense and where it can be done without jeopardizing safety. So we're not opposed to sharing. We just need to make sure that that sharing doesn't put the critical safety applications at risk. Today's market is enchanted by driverless vehicles. They're creating tremendous excitement around the industry and around the world. The future of autonomous vehicles would benefit greatly from federally funded research, conducted in partnership with the academic institution, United States Department of Transportation, and the private sector to model the safety benefits of commercially available autonomous motor vehicle technology. Furthermore, both autonomous and connected vehicles produce incredible amounts of data which will need to be collected, analyzed, and secured, in some cases made available. While this provides a tremendous opportunity for innovation, new businesses, new opportunities, our future transportation network faces real threats from cybersecurity attacks and real concerns about driver anonymity in this system. Sustained research and development will be critical for ensuring uncompromised security, and whereas autonomous anonymity is already possible through the dedicated short-range communication protocols, which allow for beaconing between vehicles as well as between vehicles on the roadside. Such communications create immediate awareness for the driver and the vehicle surrounding it, but cannot enable recognition of other vehicles. In summary, vehicle-to-vehicle technologies represent the future of surface transportation, safety, mobility, and traffic congestion mitigation. With more than 33,000 fatalities annually on our nation's roadways, continued full funding of the ITS research program will be critical in reducing these preventable tragedies and keeping the United States ahead when it comes to transportation and our transportation system. The innovations that we'll talk about today will be showcased next Wednesday at the Cannon Caucus Room at the ITS America Technology Fair, and I invite you all to come and see these technologies. They'll also be showcased in Detroit in September at the 21st ITS World Congress. We'll be demonstrating autonomous vehicles, connected vehicles, and the whole suite of ITS technologies. I thank you for the opportunity to testify and look forward to answering your questions.
Thank you very much. I now recognize Mr. Maddox for 5 minutes to present his testimony.
Good morning. Thank you, Chairman Bouchon, Ranking Member Lipinski, Chairman Smith, and all the members of the subcommittee for the chance to speak with you today. I'm honored to speak on behalf of Texas A&M Transportation Institute about the future of surface transportation technology and key research needed for creating a much safer and more efficient transport system. Transportation is the lifeblood of our economy and society. Our current surface system has served us well for the last 100 years. However, it is showing signs of strain. Yet our society, economy, and international economic competitiveness depend directly on the ability to transport people and goods in an efficient manner. Largely, we've accepted undesirable outcomes of crashes, congestion, and wasted energy, as stated earlier, as the status quo. We've attempted to address these problems, of course, primarily with separate, siloed approaches for vehicles, roads, and human behavior. But those separate approaches are only producing incremental results instead of the significant breakthrough improvements that we need. It is clear we need a significant change. The next wave of breakthrough innovation will be connected vehicles, first connected to each other through V2V, then to roadway and infrastructure devices through V2I, then finally to other vulnerable road users, such as pedestrians, motorcyclists, and bicyclists. And collectively, these technologies represent a critical component of the transportation future. The first of these, V2V, has a foreseeable path to deployment through a NHTSA mandate or consumer information program, though focused and applied research remains needed to bring it to a point where it is ready to be deployed at scale. This includes research to support NHTSA's rigorous rulemaking process, research on spectrum congestion, and field testing of the security credential management system, which is critical to the operation of that V2V system, amongst others. Policy is equally important, and significant progress has been made over the last 3 to 4 years, but additional research is needed in a few key areas. Privacy has been one of the key policy aspects identified since the inception of the V2V program. The V2V system has been designed from the very beginning to be very protective of privacy of individual drivers or vehicle owners or operators. And the result is that the basic message that is broadcast from these vehicles is anonymous and contains no information that identifies the vehicle or driver. By design, the system does not track or record vehicle movement. Because of this, it is practically impossible to track the location or meaningful path history of a vehicle or person through the V2V system, as contrasted to the relative ease of doing so with cell phones. Additionally, similar protections are designed into the security credential management system that is being finalized by the automotive OEMs with help from experts in academia and the security industry. Of course, no electronic data system is completely impervious to cyber attacks and hacking, and vehicles are potential targets of such attacks. Therefore, it's prudent to continue conducting research on that topic for vehicles and infrastructure. Liability concerns may slow U.S. deployment of fully cooperative systems. Other countries may very well benefit first from the technologies developed here. Because of this, it's advised to consider policy research into shared liability regimes, including limiting but not eliminating the liability of automakers and other device makers, as well as the operators of connected infrastructure, so that we can realize the greater societal benefit of these technologies sooner. While V2V has a clear path for deployment, much research remains to be done on V2I. The U.S. needs a V2I deployment strategy that clearly supports and funds the voluntary installation of connected vehicle technology by state and local governments, and is directly supported by research and field operational tests that demonstrate and quantify the cost and benefit of these systems. These results will allow state officials to make informed decisions on whether to invest on these deployments that are beneficial to their individual transportation needs. U.S. DOT has signaled that it intends to sponsor such V2I field operational tests in the 2015 through 2018 timeframe. This is a critical step towards deployment of V2I, and this research effort should be fully funded. Importantly, vulnerable road users make up 30% of our traffic fatalities, and this is a growing number. Research must be funded and started on establishing connected applications for their safety and mobility, including V2P, V2 pedestrian, V2 bicycle, and V2 motorcycle. Alongside the development of connected vehicle technologies, research and automation will occur simultaneously. These technologies are not competing against each other, but are actually very complementary. Automated vehicle research is proceeding at a rapid pace, but it is clear that operation of these vehicles will rely on having a human in the driver's seat for some time to come. This is partially due to technical limitations, but also to yet unanswered policy questions. The U.S. DOT can help the industry develop these AV technologies with studies on how connection complements automation, how improved or enabled infrastructure can aid automated vehicles, and policy research would be very helpful, as U.S. DOT is in a unique position, along with the state DOTs, to begin to address some of these key questions. In closing, U.S. DOT, along with industry, academia, and other governmental bodies, should continue its very successful public-private research program on connected transportation and be funded to finish the work we've started on this technology, as it holds great promise for improving our transportation system and our economic competitiveness. I appreciate this opportunity very much. Thank you for your attention. I look forward to your questions.
Thank you very much for your testimony. I now recognize Ms. Tabar for her 5 minutes.
Thank you, Chairman Bashan, Ranking Member Lipinski, and members of the committee for giving me this opportunity to testify before you this morning. Toyota has a long-standing and unwavering commitment to research and development. As the world's top-selling automaker, Toyota spends over $1 million per hour globally on R&D activities that range from basic research to the development of new technologies and products. This commitment is evident in the U.S., where we have world-class R&D facilities. For example, the Toyota Technical Center where I work is Toyota's leading technical center outside of Japan. Today we have over 1,100 engineers, scientists, and technologists that work at our facilities in California, Michigan, and Arizona to develop the smartest and most advanced vehicles. The automobile is currently undergoing a technological transformation that is reducing crashes, improving fuel efficiency, and bringing greater convenience and improved quality of life to the drivers and passengers. Much of what is to come will be made possible by the increasing level of connectivity, including the ability for the vehicles to communicate with each other and the infrastructure around them. Vehicle-to-vehicle, or V2V, and vehicle-to-infrastructure, or V2I, communications are such technologies. The revolutionary advances in the sensor-based technologies that we are bringing to the automotive safety can be enhanced even further through these V2V and V2I communication technologies. They have greater range, better field of view, and better line of sight than the sensor-based technologies, and therefore can identify collision threats at a much longer distance or with a vehicle that is out of sight. It is complementary to combine these technologies with the communication technologies and onboard sensors that allow us to make progress towards our ultimate goal of zero casualties and zero vehicle crashes. Although our initial focus is on safety applications, the technology will be used for many other applications beyond the collision avoidance. For example, it can be used to assist with navigation, making electronic payments, for example, tolls or parking, improving fuel efficiency through speed pacing at traffic lights, or gathering and disseminating real-time traffic information. This type of technology also unleashes the creativity and innovative spirit in connected car applications that are just now starting to be imagined or envisioned. Toyota is committed to this critical safety technology. In Japan, we have already commercialized the first generation of V2I communication technologies and providing detailed traffic information, lane merges, and other road condition information. In addition, several months ago, we announced the commercialization in Japan of an automated highway driving system. This revolutionary technology will combine next-generation lane trace control and cutting-edge cooperative adaptive cruise control that will use V2V communications to help maintain safe distance from the vehicles in front of you. We intend to bring these technologies to the U.S. market in the very near future. A few key challenges do remain, but there are a number of steps that Congress and the federal government could take to help us overcome these. First, the federal government should preserve and protect the spectrum that is necessary to support these communication technologies in the U.S. The use of the spectrum allocated for V2V and V2I communication is by unlicensed devices raises significant concerns about harmful interference. This could result in undermining the integrity of the system. We cannot deploy this type of technology unless the possibility of this interference is ruled out. We are working closely with our partners to make sure that sharing of this spectrum is possible. However, this is a big technological challenge and needs time and effort and testing to prove out. We strongly discourage Congress or the FCC from taking any further action to force the sharing before a viable solution is found. Second, the V2I communication technology offers important supplemental benefits that should not be ignored. These V2I also provide a means by which the transportation planners can gain important information about how the roads are used and being used in the future. Congress and the DOT should be looking at ways to incentivize or facilitate the build-out of the intelligent transportation infrastructure and V2I communications. Thirdly, we encourage NHTSA to proceed expeditiously at the formation of the communication rules that it announced in February. The sooner we have clarity on this subject, the better we will be able to incorporate their requirements to our commercialization plans in the U.S. Finally, the DOT can play an important role in continuing the development and research for roadside infrastructure and test beds. At the same time, we're very eager to move to these commercial deployment phases of our technology, and we encourage the DOT to focus additional resources on helping ensuring a smooth and rapid deployment of the technology, including education and outreach activities. As with any new technology, there are legitimate concerns about security and privacy. However, these are of utmost importance to Toyota, and we have been considering those from the very onset. We've taken important measures to make sure that only legitimate messages and authorized devices are on the system. Thank you again for the opportunity to testify before you today. It's a very important and exciting time in the automobile industry, and I look forward to working with the committee on the benefits of this technology. Thank you very much.
Thank you for your testimony. I now recognize Dr. Barkham for his testimony.
Thank you, Chairman Buchan. Ranking.
Mike, is your mic on?
Sorry. Thank you, Chairman Buchan, Ranking Member Lipinski, and members of the subcommittee. Appreciate you inviting me to participate in this important discussion today. In addition to my role as a professor at the University of Illinois, I also wanted to mention that I serve as the Executive Director of the Rail Transportation and Engineering Center and as Director of the National University Rail Center. The new Rail Center is funded by the U.S. DOT, and it's one of the UTCs that Secretary Winfrey already referred to. In addition to our university, it includes the University of Illinois at Chicago, University of Kentucky, University of Tennessee, Knoxville, Massachusetts Institute of Technology, the Michigan Technological University, and Rose-Hulman Institute of Technology in Indiana. Prior to my position with the university, I worked with the Association of American Railroads here in Washington, where I managed and conducted research to improve the environmental and safety performance of railroads. The point is that railroads research has been the principal focus of my entire professional career of 26 years with the AAR and the university. Now, let me state at the outset that the opinions I express here are my own and do not necessarily represent those of the University of Illinois. As has already been stated, the economic competitiveness of the United States depends on safe, reliable, and efficient movement of goods and people over an integrated, multimodal transportation network. Rail plays an essential role in this system. Each transport mode has a particular niche, and use of an inappropriate mode for the incorrect task reduces U.S. efficiency, competitiveness, and environmental sustainability. Changing demands of the transportation system will require new approaches to meet 21st century needs, and effectively responding to these changes requires research to develop solutions. Railroads uniquely combine high speed and energy efficiency with the ability to safely move large quantities of heavy freight or large numbers of passengers at low cost. The demand for greater efficiency and capacity in the U.S. transportation system means that rail's already important role will increase, and research is needed to help fulfill this potential. Overseas, passenger rail transport has become highly advanced. Meanwhile, a similar transformation has occurred on North American freight railroads, which have developed sophisticated technologies that allow them to efficiently move enormous volumes of freight. This benefits the U.S. economy and society, so a significant issue facing the U.S. rail community is how to improve passenger rail service while at the same time helping our freight rail system continue to prosper. The Federal Railroad Administration, the AAR, the New Rail Center, and other organizations are conducting strategic research aimed at improving rail safety, efficiency, capacity, environmental impact, and performance, which all benefit U.S. economic competitiveness. Addressing these is a principal theme of the New Rail Center, especially as they relate to shared rail corridors. Among the challenges to implementing research is adapting regulations to take full advantage of advanced technologies that can improve rail safety. Another challenge is that rail research receives much less funding than other modes. The development of beneficial new rail technologies and solutions could be accelerated if more funding were available. The New Rail Center is a consortium of 7 colleges and universities that I already mentioned. It was formed in 2012, and it is the first rail-focused U.S. DOT UTC. Its role is particularly important because by the late 20th century, rail research and education had nearly disappeared from U.S. college campuses, with the resultant decline in graduates educated in the principles of rail engineering and transport. Ironically, this coincided with the increasing demand for such students due to the renaissance of the U.S. railroads. The New Rail Center's mission includes rail education, research, and technology transfer, all of which include significant railroad workforce development activities aimed at undergraduates, graduate students, and other students of all ages. Now, as the chairman has already mentioned, Congress understands the need for funding transportation infrastructure, and it should be equally mindful of the corresponding need for a new generation of well-educated transportation professionals to plan, design, build, and operate the most efficient transportation system in the world. The UTC research program is critical to development of the transportation solutions needed for the 21st century, and to educating the next generation of transportation professionals. The UTC program should be reauthorized in full with a clear multimodal focus that allows centers to take full advantage of all their strengths addressing interrelated U.S. DOT strategic goals. It should also allow other government agencies to fund additional centers beyond the core program. Finally, competitive selection of centers helps ensure that U.S. UTC awards are based on merit and that the program will provide maximum value to U.S. taxpayers and to the transportation community. Thank you very much. I'd be happy to take any questions.
Thank you very much. Now recognize Mr. Woodruff for 5 minutes for his testimony.
Thank you, Mr. Chairman, Ranking Member Lipinski, and members of the subcommittee. I appreciate this opportunity to appear here today and take part in this important discussion about research and development. The first slide I have today shows we have a 75-year collaborative effort, and all due respect to our friend from University of Illinois here, but with Purdue University, where we've done a lot of research and innovative projects in cooperation for the last 75 years. Annually, the state DOT, we are mandated, required to spend 25% of our SPR funds, our planning dollars, towards research. We choose to spend 40% in actual spending. That is should be an indicator about how important the state of Indiana and the DOT view this research within our transportation system. Next slide. How do we look at projects and how do we make decisions on which projects to fund? One, it has to be deliverable. It has to be in the near term and midterm. We have to be able to have it, and we have to be able to have it quickly. Any project that comes before us that we are looking to fund, it has to either make us better, faster, or be able to do something cheaper, or be able to provide some sort of a safety improvement to our infrastructure. We're looking for solutions today to the problems of today on our infrastructure. We believe in a measure versus model formula, in which case what we're saying is if we're going to do a research project, it has to be measurable. We believe that you have to be able to keep score. If you're not keeping score, it's just practice. It's not really applying. It's not helping our infrastructure. It's not helping our travelers. The recent focus areas we are looking at today, we are looking at data from probe vehicles, so that is information provided by a third party, which we get in real time. We're also looking at data from infrastructure, which has to do with traffic signal controllers and the technology that is available there at the actual signal itself. Next slide. Okay, so data from probes. You'll see a couple of different things that we're looking at. The first left half of the slide, you'll see recurring congestion. That is I-65 in the state of Indiana from one end of the state to the other, where you see those high concentrations of color. That's where we have congestion problems. What this slide does for us, it gives us another basis for making good decisions when it comes to investment of our transportation dollars. We want to solve problems when we're making these investments in what projects we pick and how we pick them. That's one way that the probe data helps us. The other is when we have accidents, crashes. You will have your initial crash. In real time, we see the queue build up. And in real time, we can dispatch our people or the state police so that we can stop the often fatal secondary crashes. Because people are coming up on the crash, they don't see the traffic stopped, and that's where you have the additional secondary crashes. So what we're able to do with this real-time data is we see where it's queuing, we can send our resources, get people off the road, get them slowed down, so that way we're making it safe today, immediately. Winter weather operations. We can look at a snow event, and we can look at the data that comes from that snow event on that day to see how traffic is moving. And that will tell us the next day, from our measurement perspective, how well did we handle getting the snow off the road? How safe did we make our roads? So in real time, we're able to get this data. We're able to make decisions in real time that allows us to, one, protect our motorists, and two, make good, smart decisions with the precious dollars we're given to make investments. Next slide, please. The other data comes from infrastructure. Whenever we talk about signals, it's how are we moving people through from green to red. So when you see those little black dots on there, those are all cars. And what we want to see is those large groups make it through our signals on green so that we have free flow of traffic, the best we can provide. Prior to this technology, you had to wait, and you would get calls from people complaining, which I'm sure none of you all get those calls. But so as you get those calls, that's when you'd saddle up a signal tech, you'd send him out there, and we would retime it based on a model that says cars should be going 35 or 40 miles an hour through it. Well, now in real time, we can make those decisions to say, hey, hold on a second, let's make sure our signal timings match up so we can get the maximum amount of cars free flowing through our roads. The other way we look at it is volume versus capacity. So if we're not getting enough cars through on a left turn lane, we only have so much volume, so much capacity, that tells us we have to readjust some other signal to add volume or to be able to handle capacity. So those are just a few examples of how we're using our R&D dollars today to solve problems today. From a policy perspective, it's just two things that I would encourage the committee to think about. One is continue to give us flexibility on funding. The more flexibility we have and how many dollars we spend towards this effort, the better for us to make those smart decisions. And two, allow us the ability to choose the projects that meet our needs so that we're funding the projects that help our infrastructure. Again, I appreciate the opportunity to appear before the committee, and I look forward to answering any questions you might have.
Thank you very much, and thank all of you for your testimony. This is actually, I think, a very fascinating hearing, and I'm going to open the line of questioning, I recognize myself for 5 minutes. There's a couple things that we were talking about. First of all, I'd like to say that, as a member of Congress, one of my roles is to make sure that the things that we do protects people's constitutional rights, and that is in the forefront of everything that we do. That said, there's a couple things that I'm interested in as it relates to information gathering and also the potential for impaired driver analysis to try, beforehand so that they're not able to drive a vehicle. I mean, anyone want to comment on the breathalyzer technology and where that might be and where the concerns are? If you come to a vehicle and you're impaired, the vehicle won't let you. You essentially can't drive the vehicle. Anyone want to comment on Mr. Maddox? Anybody have any comments on that at all? Or anybody have any information on that?
Yes, I can comment a little bit. I know that the National Highway Traffic Safety Administration, partnering with the Alliance of Automobile Manufacturers, is conducting a research program now that would look at detectors in the vehicle that could reliably detect a blood alcohol level greater than the legal limit. Whether I don't think that there's been any decisions made on that and how to move forward. I believe it's still very much in the research stage. It's an early research program. I think it is quite clear that some significant portion, I don't have the numbers off the top of my head, of our fatalities in the U.S. are related to alcohol consumption.
Well, I can tell you I was a cardiovascular and thoracic surgeon prior to coming to Congress, and as part of my training I spent a lot of time on the trauma service in Milwaukee, Wisconsin, and I would say 90% of big accidents there was some level of, that I saw coming in related to some impairment of some sort.
Yeah. I would think that if that technology, to be successful, it would have to be proven to be extremely reliable.
Yeah. And there's privacy issues, and I get that.
Yeah.
Yeah. Anyone else? Ms. Tabor?
I can add to that there are vehicle technologies today that we have available to measure things such as your eyes, where you're looking, if your head is drooping, if your eyes are drooping, if your head is turned away from the primary task of driving. And so I think in combination with that and, related to Mr. Maddox's comments, the issue here is just reliability and repeatability and making sure that it's, really accurate. And so that the technologies just need to be combined in research to make sure that we're getting the best possible results.
The other question I have, similar to that, is related to so-called black box type analysis of crash data, and we do that for airplanes, and again, there are privacy issues. I understand that, but if you don't understand why something happened, then you can never figure out how to fix the problem, right? So where are we on that type of analysis? If a car crashes, we might find out there was a vehicle failure, for example, or we might find out there was some other issue, and that might help us in our R&D. Anybody want to comment? Ms. Tabor, Toyota?
So data recorder devices do exist, and they're available. There are privacy issues additionally surrounding those technologies. There's also, we have to be careful what is actually connected to that, what are the appropriate items to monitor, and, how long does the data get stored, where does it get stored, how is that accessed, who can access it, those type of things. But certainly in the mobility industry, as you said, understanding the things leading up to, during, and post-crash are important to improve the overall safety of the vehicles and prevent those type of incidents in the future.
Anyone else? No comment? Mr.
Well, I would add, there are also other means other than vehicular. Smartphones nowadays carry accelerometers and have other data, so the privacy issue is larger than transportation. Certainly, our FMCSA, Federal Motor Carrier Safety Administration, is in the midst of a debate about electronic onboard recorders, and the privacy interests have a strong say in how that develops going forward. But it's certainly more difficult in a light vehicle setting than perhaps in a controlled fleet. But they are important issues and important considerations, and the department is in the middle of the discussion.
Thank you very much. Yeah, my son uses that technology on his iPhone when he's going down on a snowboard, and he says, look how fast I was going. It's crazy. Totally true story. He was going 45 miles an hour at one point. With that, my time has expired. I'll recognize the ranking member, Mr. Lipinski, for 5 minutes.
Thank you. I wanted to start out with Dr. Barkin and Mr. Maddox. MAP 21 made numerous changes to the UTC selection process, including instituting a peer review based selection of UTCs as opposed to the earlier earmarked system. There were some feedback that I had received afterwards from some applicants for UTCs who were not successful about the way that the review was done, and especially about the transparency. Now, you have been successful in that process, but I just wanted to ask both of you, starting with Dr. Barkin, is there any way you could see this process improved?
Well, thank you for the question, and obviously thank you for your support of transportation research in general. We did win twice, and so we're obviously happy with the process. I would say that it was very transparent. The RITA staff offered to provide us with detailed feedback on what the strengths and weaknesses of our proposal were. I think that was made available to all competitors as part of our meeting with RITA staff. We went through that, and that was useful to us in terms of modifying how we were, because there were, even though we won, there were some weaknesses identified, and we responded to those and improved, I think, our ability to fulfill those aspects, and as well as emphasize, obviously, the strengths that they saw. So I'm quite satisfied with the situation as it stands now.
Mr. Maddox, do you have any comments? Yeah.
I could add to that. We think that the UTC program is critical. I think you mentioned in your opening statement that we need a continuity of research, and the UTC program helps provide that. It allows universities to contribute on the basic and early research, and we think it's critical. Any, I guess, slight improvement could go towards perhaps making the system a bit more flexible so that a given academic organization could throw its hat in the ring for multiple UTC awards, because our organizations are very diverse, and the transportation research needs are very diverse. So putting them into one bucket or one award for a UTC program where we could be doing multiples would be a large improvement. I think also just the continuing the need, keeping with the need of this longer-term focus for the UTC program. It's difficult, of course, for any academic organization to ramp up quickly and then stop when an award stops, and the problems don't stop. So anything that could be done to broaden the time span of the awards would be a big help. But we think overall the UTC program is very successful, is very much appreciated, and should be clearly continued.
Dr. Barkin, do you have another comment there?
And I want to say I agree with my colleagues' statements. I would add one thing. I think one thing that would be helpful in future, as I said in my remarks, I think very clearly stating, assuming it's Congress's intent, that the UTC program should be multimodal. It encourages all modes, participation of all surface modes as part of the research and education program.
Thank you. I don't have much time left here, and this is a question that we could spend an hour having everyone comment on, but I'm going to throw it to Ms. Tabar, because you said Japan. From what you said, it sounds like Japan is further ahead of the United States on this. We have, across here, we have state, federal, universities, private industry. What would, ideally, how do we move forward most quickly in getting everything in place to have an intelligent system here? What would you like to see from the private industry side, if you could ideally set it out there?
So I guess to start with, we are putting it out there. I think.
Well, I'm looking at getting to the end where we have an entirely intelligent system. How do we most quickly get there?
So I think, as you mentioned, and from my remarks, Japan's side has focused a little more on the V to I as opposed to the V to V as their first step. Where in the U.S. market, we're focusing a little more on the V to V. But to get both benefits and the full benefit of the system, I think both aspects are necessary. So I think although the automotive industry is maybe making a lot of steps towards the V to V, the V to I still does need some reinforcement, and additional research is necessary to understand and test those scenarios. So I guess from our perspective, we'd like to see more collaboration and more funding towards that testing, as well as making, as I mentioned, outreach to the actual end consumer to help them understand the technology, help them experience the technology, and maybe dispel any myths that they may have about the benefits and the overall robustness of the systems.
Well, if I could just briefly follow up, is the government, federal government, doing enough, doing it quickly enough to set standards, or does that need to move more quickly?
So again, we for my comments, we are encouraged that the rulemaking and for the communications protocol has been moving forward. We'd like to encourage that to happen as quickly as possible. The automotive cycle is a little slow, and so we want to make sure that we have time to incorporate any requirements like that. So the sooner those requirements can be solidified, I think the sooner we can merge those into the market.
Thank you very much.
That was very diplomatic of you, the way you said it, a little slow.
Well, it does take time.
I
to
understand.
test it, so yes.
I now recognize Mr. Collins for his questions.
Thank you, Mr. Chairman. I'd like to start by saying all of us on this subcommittee certainly understand the importance of research and development and the appropriate use of it. We may not know even where that research takes us, and that's quite okay. But what I'm curious, maybe I'll start with Mr. Belcher. The public's fascinated with the whole concept of autonomous driving and getting in their car and so forth. And I'll later ask the question of where you think we might be 20 years from now. But does autonomous driving, could that work if you're intermixing cars that are not participating in that? You've got your 1965 Mustang out there that's not going to talk to another car. Can that work where you have intermixed intelligent cars and then others that either are and that's turned off or are not?
Sure. I think there are a couple parts to that answer. I think in some respects, the connected vehicle program that I talked about before and that we've all talked about a bit is a really great transition to autonomous vehicles, and will work really well collaboratively with autonomous vehicles. And so that you can have vehicles that are outfitted either with connected vehicle technology or with aftermarket technology that provides much of the same safety applications. So that can help you with cars that aren't autonomous. The second part of the answer is that I also think it can, based on the way that the autonomous vehicles are deployed. If you look at what many of the manufacturers are doing, it's based on a system that maps the existing space. And so for that individual autonomous vehicle, it doesn't really matter whether the other vehicles are autonomous or not. You can still maintain the safety that you're trying to do. So it's really dependent upon the deployment. I think one thing that Congress can do is to continue to fund the research on the basic deployment of safety applications associated with autonomous vehicles so that we can move to a common platform and a common data platform comparable to what Congress did in funding the Connected Vehicle Program. Without that investment, we never would have gotten to where we are today. And I think we're kind of in the same space on autonomous vehicles because we want to make sure that we don't have multiple systems that are operating inconsistently.
Thank you. I think the next question, Mr. Maddox, you mentioned how there are liability concerns, and you just let it drop on that. I wonder, when I think about the litigious part of this society and everything else we're seeing with the current GM situation, and is it billions of dollars because of a switch issue liability, whether at the end of the day liability concerns are a showstopper in the United States. And then I'd ask Ms. Tabard as from a representative of Toyota, to answer that as well, that we can have all the technology we need, but you throw those unlimited liability concerns in, could that in fact be a showstopper?
Yeah, thanks for that question. I don't think liability will be a showstopper. I think it will be a slowing down result. And why is that? If you think about these connected technologies, inherently what that means is one car company has to decide to trust data from another car company and trust data from an infrastructure device and a city that operates that device, and maybe even in the future data from a cell phone device that might be a pedestrian beacon. And so that question of, if you're making that product decision that says, okay, here's what I'm going to do to act on that little piece of data, I have to trust it. So that car companies generally are somewhat risk averse, not always, but some, and they want to make the best decision for their customer to protect their safety. And so things in the U.S. Our tort system, I believe, will slow down the deployment of the of the full functionality of the system. I think we will see early deployers. Toyota may be a very good example. But I think in general, we won't see the full benefit. And it's interesting also because if you think about the benefits, they go certainly to the driver of that one vehicle, but also that benefit goes very much to society as a whole because we have reduced congestion, reduced traffic accidents, fatalities, et cetera, et cetera. So for both reasons, I think we ought to be looking at a shared liability regime to minimize the risk of to encourage early deployment and full deployment, but also because we all get the benefit of it, therefore we should all share in the risk.
Okay, thank you. My time's expired, so unfortunately, Ms. Tabor, we'll have to wait for your answer, but thank you.
You can have some latitude. You want to have an answer?
I just, as a car manufacturer, where do you think the liability issue lies? And again, would it be a showstopper for Toyota?
So definitely we do consider the liability. It's different in each market. However, I think Mr. Maddox's comments, I echo those. It's not a showstopper. It's certainly, as he eloquently explained, it's a complex system, and so there's a lot of data sources, which just reinforces the need to do extensive testing and research before deployment. And so that's really our philosophy, to ensure that the system is as robust as possible, but given the complexity, that does take time, thus maybe back to my comment about a little bit slow to introduce. So I completely agree with that sentiment.
Okay, good. Thank you. Thanks, Mr. Chairman.
Yeah, thank you. I now recognize Ms. Kelly for her line of questioning.
Thank you, Mr. Chair. Mr. Winfrey, historically the Department has put a lot of priority on highway programs, but it seems that young people are choosing dense urban areas instead of moving back to the suburbs or to the suburbs. Can you expand on the Department's efforts to prioritize multimodal research? In other words, they don't necessarily need cars.
Right, exactly. Well, one of the areas that we're focused on has to do with pedestrian and bike safety. We realize in our monitoring the uptick in roadway fatalities. And unfortunately, that number of pedestrian fatalities is 4,400 of that 5,000 or so. So it's an important issue because at some point we're all pedestrians. So we've made pedestrian and bike safety a core issue of focus. We have at the U.S. DOT a safety council that brings together the chief modal safety officers for each of our operating administrations, and we've set up a technical team to address these issues. The Federal Highway Administration has done significant work in this area, as well as the National Highway Traffic Safety Administration. So there is a lot of effort that has been put into it. It's just a matter of increasing the focus and finding a permanent home. The DOT is set up largely by a mechanized means of transportation, and pedestrian and bike is important. but it tends to fall into the cracks. So since it's an issue of great importance, and certainly we hear from city mayors, we hear from MPOs and other entities that are focused on this important area, we're bringing our resources to bear to address it. But from a multimodal perspective, at the Office of the Assistant Secretary for Research and Technology, that's our principal mission, to focus across the enterprise and help each of the OAs get out of silo thinking or stovepipe thinking so that we're better custodians of taxpayer dollars. So we also have a research and development planning council and planning team, and that's comprised of the chief research officers for each of the OAs, focusing on a monthly basis on important topics across the enterprise. So it's a means for us to bring together and foster that collaboration multimodally.
That's very good to hear. Dr. Barkin, given that you are the only non-vehicle focused witness here, do you have any thoughts on how the department can continue to expand its investments beyond highway?
Sure. As I said in my comments, one of the things that I think should be considered in the upcoming legislation is to allow other modal administrations, the Federal Railroad Administration I would have in mind, to, if they want to add funds to the University Transportation Center program, that would be a very good thing. As I mentioned in my comments as well, we spend far less on rail-related research in this country than the other modes by a pretty considerable margin, and yet I think many people would agree that the importance of railroads is already extremely important and growing daily, both on the passenger and the freight side. There's lots of technologies that I think, or other solutions that could be developed if there was more funding devoted to rail research, whether it's through the UTC program or the FRA's R&D budget. However that can be made to happen, I think would be very good for rail and for the transportation system as a whole.
I don't know if anybody else wanted to comment.
I think we're in a transformational stage in transportation, and that really excites me. And it's not just around the cars. We've talked a lot about cars, but Congresswoman, I mean, I think you really tapped into it, and it's really the shared use mobility environment that we're moving into. And you're seeing all kinds of really interesting opportunities to provide those people who live in urban environments to utilize different modes of transportation. And that's one of the areas that ITS America focuses on, and it's trying to highlight those new opportunities. So there are now applications, like there's a company that actually has an application here called Ride Scout. Ride Scout's one of the most interesting companies around. What they do is they're a consolidator. And so you can go on to the Ride Scout application, and it'll tell you whether there's a car share, a ride share, what the transit options are, whether it's a bus, the train, how long it'll take in each opportunity, how much it'll cost, and it'll allow you to make an informed decision about what the best way to get from point A to point B is. And that's what people who live in urban centers need now. Gives you the opportunity to compare that to driving. And you can do that in a cost-effective way. Then you can actually drill down on Google Maps and figure out where you need to walk to get to that next metro stop or to that next bike share program. The thing that I think is the next wonderful stage for that is going to be a common pricing platform over the top, so that you can, once you put your data in, you can actually pay for all of those applications in one app, or for all of those transportation options in one application. We're not there yet, but I think that's the next phase for a company like Ride Scout. There are a lot of other really cool, innovative companies that are providing us the kind of information that we need to be multimodal and really take advantage of the transportation options that we've got in this country. And they're expanding on a daily basis, and it's really being driven largely by communications opportunities.
Thank you.
If we have time, I would add to that. I completely agree that ITS has to be applied to all of our transportation modes. And pedestrians, motorcyclists, and bicyclists, I think, are critically important. Clearly, there are great mobility applications, potentially, also safety applications, where that phone that you're carrying could become a beacon for you so a car doesn't hit you. And we all are in the same day, pedestrians, we get on the train, we drive in our car, some of us take a bus. The other beautiful thing about that is that phone, if you then plunk it into your 1965 Mustang, with a good antenna on the roof, it could become a connected vehicle. And if you think about how quickly we turn over phones, we get a new phone every 2 years, or most of us do. We get a new car every 5 or 10. And so we could, if through that phone as a quote deployment device, we could make all those other vehicles connected in a much quicker fashion. And I think there's a lot of research that needs to happen to protect pedestrians and bicyclists and motorcycles for safety, but also to use that as what I call a nomadic seating device to get us to that critical mass much faster.
Thank you.
Thank you very much. One thing, I'm going to just make a brief comment on bicycle and pedestrian safety. I think one of the things that we should probably loop law enforcement into that, because anyone that's driven through D.C. knows that violation of the existing laws on the books by both bicyclists and pedestrians, I think, is a serious issue. I just went around a curve, made a right turn 2 days ago. Bicyclists came inside of me, and I almost hit them, couldn't see them. They violated the law. Nothing happened. So that's just an editorial comment, but I do think that you should loop in law enforcement about what types of existing compliance issues that we have related to that. With that, I'll recognize Mr. Massey for 5 minutes.
Thank you, Mr. Chairman. As an engineer by training, I subscribe to the axiom that without data, all you have is an opinion. And so I was very encouraged by Mr. Woodruff's data that he showed and the way that it's collected. I'd like to think that regardless of which party you belong to, that your road's going to get taken care of in order of priorities that make sense. And I serve on the Transportation Committee, and now we don't have the ability anymore to direct with earmarks where these projects are going, but I feel more confident about that when I know that data is being used to drive those decisions. So really my question on this is to Mr. Winfrey. To what extent is the federal DOT using data like they're using in Indiana, anonymous aggregate cell phone data, crowdsourced data, or are we still dragging out the little rollover sensors to find out which roads are being used the most?
Again, I think we're at an interesting point in transportation history. You're going to certainly see both technologies still deployed depending on largely state resources. What we do at the DOT through our Bureau of Transportation Statistics, our data gathering efforts range from surveys to on-site data gathering. So it's a wide range of tools that we rely upon. But there are apps that we're aware of. Certainly the city of Boston has a great app for potholes, and the accelerometer in the phone and the GPS signal capability pinpoints where a disruption occurs and sends a signal to a database that gets it to to MassDOT about how to repair that pothole. You're probably familiar with that, but that's the kind of technology that we certainly see a lot of future and a lot of promise in, but that's a commercial model that needs to be built out. That's not something we have control of.
Well, I would encourage you to use at the DOT. I know you're in research, but to use as much of that data and those new methods as you can, because it's very encouraging to see it being used at the state level. I would hope that my state of Kentucky would be using it, but a lot of times politics do enter into who gets the bridge first, unfortunately. My next question has to do with mapping aids in vehicles. There was a recent article in the New York Times, June 15th, actually, 2014, said agency aims to regulate map aids in vehicles. And this caused me a little bit of concern. I'm concerned that regulations are going to make it cumbersome for these technologies to be implemented. Now, I drive through 30 miles of traffic every morning in D.C., but I've got a Tesla with a 17-inch screen that shows me where all the traffic is. And I would just ask, when we think about regulating this and implicating mapping aids in accidents, let's think back to 10 years ago when we didn't have these. How many U-turns, or 30 years ago when I was in my parents' car and my mom and dad were arguing at each other, how many accidents were caused by not knowing where you are and stopping on an on-ramp or an off-ramp or doing a U-turn where you shouldn't be. Let's make sure we consider that as the base case when we look at mapping aids. Do you think that the regulations could hinder adoption of mapping aids? Or Mr. Belcher, I'll ask you that question.
Well, I think what you're referring to is we move into the new generation of mapping and traveler information systems. We're starting to overlay crowdsourcing and gamification. So if you look at Waze or INRIX or any one of those systems, and so what those systems do to make them effective is you engage with the traveler information system itself. And so I think the question is really a safety question, and it's not any different from any other distracted driving safety question that we're all very focused on. We want to make sure that people are, when they're using these systems, are not diverting their attention from the very important aspect of driving. But believe me, my children don't use any other system unless they're part of it. This is the whole new generation that we're living with, and we want to be part of that transportation system.
Yeah, they're probably looking at the map and steering the wheel. They're probably.
Well, I hope they're looking at the road. But
but all I'm saying is that let's consider that the reason for the distraction actually may be improving safety as well by having an awareness of where you are, of where the worst traffic is, and preventing some of these extraordinary measures like taking U-turns or whatnot.
Well, we just don't want to throw the technology. I mean, I agree with you. We don't want to throw the technology out when we're trying to address important safety issues like distracted driving. We've got to figure out the right balance, and I think that's an important question.
Great, thanks. I just don't want to lose my 17-inch screen that gets me through traffic every morning.
I was going to propose a limit up to a 15-inch screen. So, thank you very much. We're going to have a brief second round of questioning. Ranking Member Lipinski and I have a couple other questions we're going to ask, and then any other members that do that. So we'll do that briefly. I want to first, Mr. Woodruff, since you're from Indiana and we haven't asked you a question yet, I figure you don't want to be left out. So we're talking about deploying connected vehicle technology. What do you see challenges that state and local governments might face in deploying connected vehicle technologies, vehicle to infrastructure, for example, and what specifically, if you can, do you think that USDOT could assist the states in coordinating that?
Well, you have to remember with the state systems, we will always adapt to the technology. So as connected cars come online into our system will adapt to that. It naturally does. So from a state DOT perspective, our focus is always going to be at the, probably the micro level, the today problem with our transportation. It will vary, but the reality is for us, the system's always going to adapt. So if cars get smarter and as they communicate with each other, that only makes our system safer. So our system we will always adapt to the technology. Now, what I have found on the state level is normally a lot of the issues, I know that the Congresswoman, I noticed she had left, but when you think about, pedestrians, or our system will always adapt to that. If we start to have an issue with people crossing the roads, we will have to come up with a solution at a state level. And very rarely can we wait for that solution to come from, say, the state or the DOT. So we have to move that way. But to answer your question, it would adapt. It just naturally would over time. But we have to deal more with the reality that, like my son, he drives a 2000 Mustang, which is probably a bad decision on Dad's part. But so his car's not going to communicate. So we have to look out for those passengers today.
I'm also interested in long-term research and development, mainly on traffic patterns. Like, I'll just comment on Evansville, for example. I moved to the east side of Evansville, Newburgh, which is right outside Evansville. And when I moved there in 1999, the major, really, highway going through Evansville, what's called the Lloyd Expressway, really hadn't extended out that far, and there was nothing there. But it was very clear to me and to many others that this was going to be potentially an area of growth, and in the long term to prevent traffic snarls and backups. What's kind of the long-term vision and how the state DOT looks at those type of things, and is there ongoing pattern research in that regard?
Absolutely, and when I showed the one chart that had the multi-callers where we may look at an entire corridor, we would do the exact same thing with the Lloyd Expressway, where we know today, where are the backups occurring. When we plan for our infrastructure improvements, if we need to do an interchange at Burkhart and Lloyd, for instance, that would be yeah, I'm sure we do. That would be one that would have that high visibility of callers, so we would know that. So a lot of times when we see those as it stretches back, we would make those investments because it would actually have a positive impact where we are currently having a traffic problem. So when we plan out, we do look to the future on those projects to say, all right, what is this project? How will it impact our current problem here? And maybe that is a cheaper alternative so that we can stretch those dollars further by doing something futuristic to say, well, maybe if we put an interchange 5 miles back, the traffic will start using that area as opposed to up here, and we may not have to build an interchange here.
Yeah, I think that's a very important issue because in the larger context of what we're talking about in Congress as it relates to emission control, not only with, and other environmentally related issues. I mean, if you look at, and I don't have the numbers in front of me, the amount of fuel, for example, that we burn sitting in traffic, wasted, just might as well throw it away. The amount of emissions that are a result of traffic snarls around the country. I see that type of research, in traffic patterns being really critically important to the larger discussion we're having in America about how we utilize fuel, how we improve our environment, and make those things meld together. So, thanks for that information, because I do think that vision, and sometimes I think Congress needs a little assistance in having a longer-term vision versus a today. You have to have both, of course, as you've commented on. But I think, had we looked ahead many, many years ago in certain areas of our country on population growth and that, we probably could have mitigated and directed resources to improving the infrastructure in those areas ahead of time that may have very well have prevented a lot of the wasted fuel and environmental impact that we see today. It's tough because of the funding, and I get that. But I really am very interested in how moving forward we really need to know this. That's why data, as Mr. Massey said, data is critically important. So I'm going to recognize Mr. Lipinski.
Thank you. Yes, data are critically important, but I hope no one latches on to the first part of what Mr. Massey said and thinks that because we don't do earmarks here in Washington that we are the money is being spent according to data, because I assure you the governors and state legislators are not spending the money by data. So always like to make that point, because I always think earmarks are something Congress should be doing. But and I know Mr. Massey got to that point about politics still being very much involved in
I assure you there's not enough data in Kentucky either.
I'm going to give this to Mr. Belcher, and just because of your position, I'm sort of looking for an idea about where we are going and how quickly we're going to get there. Where are we going to be 5 years from now, 10 years, 15, 20? I'm not sure how long all this is going to take, but I'm just sort of looking for an idea, a vision of what is the future going to be like and how quickly are we going to get there. 5 years from now, how much intelligent transportation, how much is going to be in place? 10 years from now, 15, and where do you see this? How quickly do you see this coming about? Because we've talked about all these different ideas, V to V, V to I, and then bringing in pedestrians, cyclists. How quickly do we get there? Can you give some idea? And that's a very tough question, but you must, being President CEO of ITS America, you must have some ideas about this and how quickly we're getting there.
You decided to give me the easy one, right?
Yeah. Well, I'm sure someone else would love to take it if you.
Yeah, I'll take a cut at it. I think we're at a position unlike any other time in our history with respect to transportation and what's possible. Congressman Massey talked about data. I mean, we're just barely scratching the surface of using data in meaningful ways and using data analytics. And so if I look at the data that we've got in the transportation system and the data that Mr. Woodruff talked about at the state levels, right now we've got isolated segments of data. So the state transportation system's got one pillar of data. The transit system's got another. The emergency response system's got another. You know, and in any given city, you might have 20, 25 different data systems. And so we're at the point, we're getting close where you can start to scrape those data systems and to utilize them in an intelligent way. Once you start to do that, then you can start to manage transportation not just in a block by block and not just in a city and not just in a single mode, but start to manage transportation on a regional basis and a multimodal basis. That really opens up opportunities that we currently can't do. And we're going to have to use things like data, things like technology, because quite frankly, I don't see a big investment in our infrastructure coming anytime soon, even though it desperately needs it. And so the states and the cities are going to have to look, one to technology, two to the private sector. I think we're going to see greater partnerships between the public and the private sector. And you're going to see opportunistic deployment. So a perfect example is in Southeast Michigan, both Toyota, the University of Michigan, the state, other private sector agencies, the federal government are invested in the first real deployment of connected vehicles. And that's going to happen over the next 3 to 5 years. Going to move from 3,000 vehicles in the safety pilot to 30,000 vehicles in Southeast Michigan. This is going to be before the rules come out. So what can Congress do? Congress can make sure that as we do this, we protect those bold people that are willing to take the risks, willing to get equipment, willing to make investments, so that they're grandfathered when we finally get the rules. Because if we don't take advantage of the spectrum we've got, we don't take advantage of the opportunities that we have over the next 3 to 10 years, we're going to lose it. And so it's going to take bold people like Michigan, like Florida, like Texas, like Indiana that are going to be early adopters, that are going to partner with the private sector, going to partner with universities, and start to see deployment. So I think what you're going to see over the next 5 to 10 years is I do think you're going to see adoption of connected vehicle technology. I think it's going to happen before the rules come out. I think you're going to see it in cities where you've got courageous leaders that we can protect. I think you're going to see it in university centers where you've got universities that are willing to put their money where their mouth is. And you're going to see the private sector pushing this along in very, very aggressive ways. And we're going to do it in partnership with the federal government. But I do think it's going to happen. We're going to have to move more quickly than the federal government's capable of moving. We're going to have to move more quickly than vehicle fleets turnover. And so I do see that. The final thing that I'll say, because I could talk about this forever, when I talked about the shared use mobility, I really think that's part of the future. I think we're going to start to see people, especially a younger generation, that don't have the same interest in owning cars that we had. I mean, I had a car when I was 16, the day I turned 16. That's changing. You know, what's far more important is being connected. And the cars are just becoming a node on the network at this point, especially in the urban environment. And so we're seeing different ownership models. I mean, every automobile manufacturer now has a car share, company, or is thinking about one. Think about that. So that's the future we have. It's really exciting. It's hard to predict, but it's going to be it's exciting, and I think it's going to be a lot of fun.
Thank you.
Or in D.C. or other cities, you have a car when you need it. You get a zip car if you need a car that day. If you don't own a car. Recognize Mr. Massey for 5 minutes.
Well, to use a transportation analogy here, I'm going to flirt with the third rail and talk about funding. and not funding for your projects, but funding of transportation in general. Because I'm on the Transportation Committee, and we've got a shortfall that we have to deal with. This is partly a result of not indexing the gas tax. It's been the same it is right now for 20 years, while at the same time the CAFE standards go up and alternate fuel vehicles are on the road. And nobody wants to be a freeloader, I think, and people value surface transportation and roads and whatnot. But talk to me a little bit about how technology could help us with an alternative, and whether it helps the federal government, whether we decide to come up with that shortfall in transportation and infrastructure at the federal level, or whether some of these obligations get devolved to the states and cities like you were talking about. Somebody's going to have to pay for it, and it seems like the gasoline tax is if not outdated now, is going to be outdated in 10 or 20 years. How do we solve these problems with technology? Mr. Belcher, I put you on the spot again here.
Well, I think where you're heading is you're probably curious about mileage-based user fees, and I think that's really where we're probably ultimately.
Yeah, user fees I think are the best. Put the cost right there where it's being used. So please go ahead.
Yeah, I think Congressman Blumenauer has a bill that he's introduced about opening up the use of mileage-based user fees and some additional pilots. The state of Oregon, there have been a number of states that have done pilots. I think the legislation that's been adopted in Oregon is actually pretty interesting, and it deals actually with electric vehicles right now. And what their experience has been is that people need choice, and that the technology solution that we may all be enamored of may not be the best solution. When they tried to implement a pure technology solution, they got a lot of pushback from the public. And so what they found is they needed to give the public options. And so now within their legislation, you can pay a flat fee on an annual basis. You can pay a fee that's based on your odometer on a regular basis, or you can actually utilize the technology that's available so that you can get, you can actually pay for what you use. The technology's there to do that, and you can do it with GPS technology pretty easily. The biggest challenge I think that we have to overcome is the administrative cost of administering the system. So right now the gas tax is amazingly efficient. We spend very little money administering it, and it's very efficient across state lines. When you start to get into a mileage-based user fee system, the back office costs are much higher, and so we've got to really focus on bringing those costs down and reducing the costs of managing it across state lines. But the technology's there. It's more policy issues in my mind.
So one of the policy issues that's going to be inevitable, though, is privacy as well. And Mr. Maddox, I think you talked about how you can anonymize, makes anonymous some of the peer-to-peer stuff. But how would people retain their privacy in a vehicle miles traveled sort of situation, or a toll, maybe micro tolling? How would they maintain privacy in that situation?
Yeah, and I was actually going to interject the same comment that we need to be very careful about that. The V2V system as designed is designed to be completely anonymous. When we ask for someone to pay using that system or a related system, by definition, it's no longer anonymous. In fact, it has to be very personal, and your location has to go along with it. So I like Scott's comment about the fact that in Oregon they realize they need a bevy of solutions, and maybe the best solution is not the one that's the most precise, i.e. not the one that relies on knowing exactly where you are and who you are at the same time. Maybe there's a better solution that's a little less complicated and perhaps even a little less administratively costly, that still protects privacy but provides a generally accurate cost basis. I don't have an answer what that system is, but I do know that we need to be very careful when we want to use a system designed to be private to be no longer private.
Right. Well, just to throw something out there, one idea that I've thought of is instead of sending my GPS location to the cloud and telling everybody where I am every second and then let them computing the cost of my trip, send my car or my phone the cost of the roads per mile that I'm going to travel on, and my phone or my car could calculate that. And so all that I transmit to the government is what I owe in tolls that day or that month. You wouldn't even need to know how many miles I drove. So I think there is a way to do that, and I think if we're going to use an alternative payment method for the roads, we have to solve that problem. Otherwise, the public won't support it, and I wouldn't support it either myself. So.
Yeah, and I do agree with you. I think there are probably many creative solutions if we put our heads together. There is a large policy question that goes along with it, and once we get past that policy question, I'm sure the technology would be capable. I'm sure we could come up with creative solutions that still protect privacy.
Thank you very much.
Thank you very much. I'd like to thank all the witnesses for your valuable testimony. This has been very important. Like I said, it is important for a bigger context to where we are in our country as it relates to a multitude of issues, as we've heard today. The record will remain open for 2 weeks for additional comments and written questions from members. In fact, I probably will submit some questions regarding spectrum, because one of the takeaways from here today, I've heard from multiple witnesses, is concerns about spectrum. That's not under the purview of our subcommittee, but I think having that, the answers to those questions on the record, congressional record, is going to be extremely important. It may be open for 2 weeks for additional comments and written questions from members. Please answer back as quickly as you can so that we can get that to be part of the record and get that information. At this point, the witnesses are excused and the hearing is adjourned.